Hey, welcome to the 16th session, can you believe it, of AP Calculus Flipped Classroom. This is section 2.5, the chain rule. Chain rule is used to find the derivative of a composite function. If you remember, a composite function is a function that is composed of two or more functions. Consider the function y equals 2 times the quantity 3x minus 5. This function is a composite of two functions, which we can call u, or u of x, and that would be equal to 3x minus 5. That would be our inside function. And then y of u, and if u is 3x minus 5, y of u would be equal to 2u. The derivative of y of x is the derivative of the inside function times the derivative of the outside function, which is then evaluated in terms of x. You may say, what the heck am I talking about? Let's see if we can straighten it out. More info. Okay, if we start with y of x, its derivative can be written as dy dx. That means find the derivative of y with respect to or in terms of x. The derivative of the outside function, y of u, would equal dy du, which means the derivative of y in terms of or with respect to u. Derivative of the inside function, u of x, would simply be du dx, which means take the derivative of u with respect or in terms of x. By the chain rule, the derivative of the composite function, dy dx, equals dy du, the derivative of the outside function, times du dx, the derivative of the inside function. Since the final derivative should be in terms of x, you must evaluate dy du in terms of x when you're all done. Here's a simple problem. This is the problem we started with at the beginning. Y of x equals 2 times 3x minus 5. Let u of x, our inside function, equal 3x minus 5. Therefore, du dx, the derivative of u with respect to x, would just be 3. Let y of u equal 2u. That would be our outside function. Dy du, the derivative of y with respect to u, would just be 2. Dy dx is the product of dy du, the derivative of the outside, times du dx, the derivative of the inside. Therefore, dy dx would be 2 times 3, or 6. You can verify that this answer is right in this particular problem by just multiplying out the original problem. Distribute the 2. You would get y of x equals 6x minus 10. If you took that derivative, you would get 6. Notice, you get the same answer. Here's a little harder problem. Let's say y of x is equal to the quantity 3x minus 5 squared. In this case, we'll let the inside function be u, or u of x, and it would be equal to 3x minus 5. The outside function, y of u, would simply be u squared if u is equal to 3x minus 5. So y prime of x, or dy with respect to x, would equal the derivative of y with respect to u, that would be the derivative of the outside function, times the derivative of u with respect to x, the derivative of the inside function. Dy du is 2u because y of u was u squared. Du dx is simply 3 because u of x was 3x minus 5. Put them together, we get dy dx equals 2u times 3. But you must express the derivative in terms of x, so 2u would be 2 times the quantity 3x minus 5 by substitution. So dy dx, the derivative of our original function, would be 2 times 3x minus 5 times 3, or simply 6 times the quantity 3x minus 5. Another one. This time I've changed the variables on you, and I'm saying s of t equals the sine of the quantity 3 pi t over 2, or 3/2 pi t, plus the cosine of 3/2 pi t. Okay, remember, ds dt is what we're looking for, is equal to ds du, the derivative of the outside function, times du dt, the derivative of the inside. Let's break this into two problems because it is the sum of two functions. So we're going to do the first part of the problem first. S of t, I'm going to say, you can think of it as S sub 1 of t if you want. I'm going to say that equals the sine of 3 pi t over 2. Okay? I'm going to let u, or u of t, be the inside function, in which case that would be 3 pi t over 2. Du dt, in this case, would be the derivative of 3 pi t over 2, and that would just be 3/2 pi. Okay, s of u, which is the outside function, would just be sine of u, because u in this case is 3 pi t over 2. Taking the derivative of s with respect to u, I get cosine of u. So, putting them together, ds dt equals ds du, derivative of the outside, times du dt, derivative of the inside. And I get, my last line here says it's the cosine of u times 3/2 pi. But it needs to be with respect to t. We're looking for ds dt. Therefore, I substitute what u was into the cosine of u, and I get cosine of 3/2 pi times t times 3/2 pi. That is just the derivative of the first part of the problem. The next slide gives us the second part of the problem. It's very similar. Let S2, if you want to think of it that way, of t equal cosine of 3 pi t over 2. Let u be the inside function, so u of t would be 3 pi t over 2. Du dt, in this case, is 3 pi over 2. Okay? S of u, our outside function, would be the cosine of u. The derivative of that, ds du, would be negative sine of u. So putting them together, in this case, ds dt would be ds du times du dt. Substituting what those values are, I get ds dt, the derivative of s with respect to t, equals negative sine of u times 3 pi over 2. But something's wrong. It's not in terms of t. So I have to substitute what u is. So negative sine of 3 pi t over 2 times 3 pi over 2. That would be the derivative of cosine 3 pi t over 2, our s of t in this problem. Let's put the two answers together, the one from the previous slide and this one, and I get cosine of 3 pi t over 2 times 3 pi over 2 plus a negative sine of 3 pi over 2 times 3 pi over 2. I could factor out the common term there, 3 pi over 2, and I would get 3 pi over 2 times the quantity cosine of 3 pi t over 2 minus sine of 3 pi t over 2. If you want to do that, you can. Okay? Practice problems. Here are some problems where you need to use the chain rule twice. That should actually be there are some, I'm sorry. And we will discuss how to do that in class tomorrow. Please work on page 195, numbers 1 through 32. If you come across some that need to be use the chain rule twice, a composite of a composite, I will show you how to do those tomorrow in class. They're not difficult. Thank you and have a good night.